Alright, so a question like this would be asking you to kind of do different characteristics of a quadratic. We have a graph here. This is just for visual, though. Everything I'm going to do here is based off of this function, because I don't trust graphs. I trust the function. So, some questions that you might have to answer. You might have to find axis symmetry, vertex, yada yada. I'm not going to read all that to you. But, again, this is characteristics of a quadratic. So, there are some things we should just know by looking at it. Clearly, looking at the graph, it opens up. Why does it open up? Well, look at A. A is the one that's attached to x, because standard form is ax squared plus bx plus c. Ooh, that's a 6. Yeah, I meant to write c. Okay, let's get out the old eraser, see what we can do. Alright, let's try that again. Plus c. There it is. Alright, so, where was I? A is a 4. That's positive. If A is 4, it's positive. It opens up. So why does it open up? Well, it has a positive A value. The zeros, I guess we can trust the graph on this one. It's where it's crossing. It's crossing at -2 and 0. I don't write this as a coordinate because it's not a coordinate. It's two values where it's crossing the x-axis. -2 and 0. Later on, you'll learn about how to find those if you can't exactly see it or if you don't trust the graph. So domain. The domain of this thing is going to be all real numbers. Any quadratic will have a domain of all real numbers. Why? Because you can plug in an x value and get out an answer. The fact that you get an answer means that it's in the domain. This one has an axis of symmetry that you can see right there. But let's go ahead and find it algebraically. Formula for axis of symmetry is negative b over 2a. What this means is whatever the b value is, in this case 8, because that's attached to the linear term, it's attached to x. Whatever the b value is, you don't make it negative, you switch the sign on it. So it was positive, it becomes negative. If it was negative, it would become positive. Divided by 2 times whatever the a value is. The a value in this case is 4. So what we're really looking at here is negative 8 divided by 8, which is a -1. There's the axis of symmetry. The axis of symmetry is a line. It's a vertical line, so you have to say x equals. X equals whatever we just calculated. So x equals -1. The nice thing about this is that is also the x value at the vertex. So we're halfway done with the second part there too. To get the y value, you're going to go back to the function. Y equals 4x squared plus 8x. And you're going to plug that axis of symmetry value, that x value, into this function and solve for y. So it's 4 times -1 squared plus 8 times -1. -1 squared is 1, so that doesn't really change anything. It's just 4. That makes -8, so 4 minus 8 is -4. There is the y value of my vertex. Now, this piece of information also gives us the maximum or minimum value. To decide whether it's a maximum or minimum, look at A, see how it's opening. Since it's opening up, we have a minimum value, because there is a lowest point at which this function is going to go. If we look at the parabola, kind of trace along, going down, 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 down. Oh, low point, turning point, now we're going back up. So there is the minimum, right there. And the minimum is actually going to be a y value. It's the y value at the vertex, which is what we found right here. So the minimum value is -4. The range is tied to the minimum or maximum value. The range, if you remember, is y values, just like domain is x values, in this case all real numbers. The range is a y value, so the range is tied to -4. Now, if we're thinking about values we can get out, we look along this line, we're getting all sorts of values. Positive and negative. But are we getting any below -4? Well, no, because the parabola ends. So, it's going to be y is greater than or equal to -4. It's greater than or equal to because we can get exactly -4 by plugging -1. That's our minimum value. So there you go. End behavior. End behavior is you are looking at when x approaches infinity, what is y going to do? And you're looking at when x approaches negative infinity. What is y going to do? Those are some pretty good infinity signs as far as mine go. Alright, so let's look at the graph. As x is approaching infinity, as x is going this way, as x is going this way towards infinity, what's y doing? Well, let's just start here at the vertex. We're going towards infinity, so y is going to keep going up, 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 and up, and up, forever and ever. So we will say that y is approaching infinity. And behavior for negative infinity. Negative infinity would be x going this way. Yes, that's an arrow towards negative infinity. So, again, start at the vertex and start going to the left. What's the y value doing? Well, it's going up. As you move to the left, the y value is going up. X is going down, but y is going up. So, end behavior is as x is approaching infinity, so is y. And as x approaches negative infinity, y approaches positive infinity. You will find this end behavior to be the exact same for any parabola opening up. So, there you go. A little bit of characteristics of parabolas.